I now want to look at the construction tolerances and the stitch tool in a bit more detail. And we know that the stitch tool uses the gap distance in the construction options to check for gaps and to create closed shells. But now I want to have a look at what else it does to help us export solid models. So I'll create a cylinder, which is something that we think of as being a solid object. But in Alias it's just a set of 3 surfaces. To make it solid, the surfaces need to have these normals all pointing outwards, as that tells a CAD system or a machine tool that inside is solid and outside is fresh air. But in Alias we can have normals in any direction, so some might be pointing out and some inwards. And that's not going to make sense as a solid object. Now I've got another tool here on my orientation menu which will show us the normals in surface colours. So blue is pointing outwards and yellow inwards. And this is really easy to work with because you just click on a surface to flip the normal outwards. So I could go around and switch all the surfaces myself. But it's one of the things that the stitching tool does for us. Now if I check my surface normals, you can see that the stitch shell has all the normals unified and pointing outwards. So having no gaps between the edges and all normals pointing outwards equals a solid model. And I've also got an unstitch tool here. And I'm just going to set that at Keep Originals. And then unstitch that shell and move it off to the side. And you can see that the unstitched one has been changed. The surface normals are now flipped. So if I go from my normal surfaces to my stitched and then unstitch, I don't get back to exactly the same thing that I started with. And actually there's more changes. If I pick these surfaces, you can see that the stitching has split them up. And that's one of the options on the stitch tool. Here, detach the periodic surfaces, because some solid modelling CAD systems can't handle periodics. So I'm just going to get rid of those, and then I want to make my surfaces a bit more complicated and add another cylinder, but this time without end caps. And I'll use that to punch a hole through the middle. And I'll just make it a bit smaller that way and a bit longer that way. So then I can intersect that with that, and then trim that one and that one. And so I've got a hole. And if I check all the surface normals again, then I've got some going inwards, some going outwards, which is normal. But what's interesting here is that when I stitch this, we get a problem on this intersected edge. And that's actually to do with our construction options. So on this CATIA preset, if I come down to the tolerances, there's not just the continuity, there are some other sections as well. And here's the one for trimming. And you'll notice that this is set to 0.005, which is larger than 0.001. So when I intersected and trimmed, it only worked to this looser tolerance, which is why it failed when I stitched at this tighter tolerance. So that's not really satisfactory. So what most people do is choose one of the presets to start with, and then copy it and rename it for their own settings. And once it's a copy, you're free to change any of the settings you want to. So I can now tighten up that tolerance to being the same as the gap distance. And also I'm not really happy with this gap setting here, so I'm going to set that much smaller as well. So now that I've got these in sync, then I need to redo the intersect and trim. So I'll untrim those two, and then delete the curves on surface. And then do a new intersection, and this time it will be calculated at these tighter tolerances. So once I trim, then I can try stitching again. And this time I haven't got any problems, because I built at a tight tolerance and checked at a tight tolerance. So let's see what happens when we unstitch. And I'll move that one over again. So we know that it splits up the periodic surfaces, but it also does something similar to the trimmed edges. So if I just do a curved duplicate here, it creates a single periodic curve. But if I do the same over here and just use duplicate again, then those trimmed edges are split up. And it's done that because of another setting in the stitch tool, which is detach single curve boundaries. So all of these settings help to prepare the Alias surface model for export as a solid. But they're also one of the reasons why I strongly advise that you keep the original surfaces on when you stitch. So let's see how all of this applies to our charger design. So we've got the base and the frame surfaces. And now if I take a look at the surface normals, then we've got a mixture, which is what we'd expect. Because in Alias, the normals don't matter that much. They don't affect the shading. And so as we're modelling, we don't tend to pay much attention to them. And anyway, we can always use the stitch tool when we're ready for doing data transfer, as that will then unify all the normals into the same direction. And in this case, they're just pointing inwards, so I can just click on it to switch them to pointing outwards. And that's what an engineering CAD system needs to recognise it as a solid. So if I'm ready to get this prototyped, then I'll need to check that the mirrored sections will stitch. So I'll do that one, and that's fine down the centre line. And then I can mirror it in the other direction to complete the model and just check that that's stitching as well. So this is ideally what we're aiming for, all orange edges, which means it's completely solid. So I've finished checking, and now that I'm ready to export, then I don't really want to move these away from the centre line because I want to export them on the origin. So what I'll normally do is just have a new layer and assign the stitched objects onto that layer, and then turn off my original surfaces. And if I open up that layer, you'll see that the objects are called shells, and the symbol is this solid-like object. So I can export out the normal surfaces, but I'll generally get a better result if I export the shells. So I'll tidy these up and name them. And then when I'm ready to export, I'll just choose the two shells. And I don't want to do a file save, as that will have all the curves and construction surfaces included. Instead, I'll do an export active as, and go into the option window to choose the format. So I've got some which are proprietary, like CATIA and Pro-E. I've got OBJ, which is a polygon format for exporting to 3D Max or Maya, etc. And the ones I'll use most for manufacturing output are IGES and STEP. So I'll start with an IGES, and unless you've got specific requirements, then normally I wouldn't bother changing any of these settings. So I'll just save that and call it Charger 1. And whilst I'm here, I'll export out a STEP as well, so that we can see the difference. And again, I won't change any of the settings. So I'll just call that one Charger 2. And then let's see what happens when I open them up. And I've got all files set here so I can see it. And I'll open the IGES one first. And I'll stick with my tolerances. And it comes in on a layer, and it's kept the names, but they're not shells, they're just groups of surfaces. And I'll typically do this. I'll open my exported files just to check that everything's okay before I send it out. So let's take a look at the STEP file. And you'll notice I've got this log file, and it's just a small text file that we don't need to keep, so I'll just delete it. So I'll open up the STEP, and it gets translated, and I'll keep my tolerances. Now that doesn't come in on a separate layer, just on the default one. But it's a group of the two stitched shells. So it keeps the shells and it keeps the names, and just groups them together. So if you were to bring in a file from a different CAD system as a STEP, it might come in stitched, and you can't add fillets or work with the stitched surfaces. So you'd need to take that and unstitch it back to normal NURB surfaces so that you could continue working on it. And I had Keep Originals on here, so I've still got both the shells and the surfaces showing there. So one final tip is that the exported files can be large, but they compress really well. So that one's 80% smaller. And it's the same with the STEP file. Whereas the alias files don't compress much at all. So it's worth doing that if you're emailing the file to your supplier.